Welcome you to the lecture for section 12.1. This is MGF 1106 Liberal Arts Math. My name is Jorge. So the objectives for this lesson are the following. So we're going to learn how to count elements in a set systematically. We're going to use tree diagrams to represent counting situations graphically. And we're going to use counting techniques to solve applied problems. So systematic counting, essentially, here's an example. How many ways can we do each of the following? Flip a coin, roll a single die, which is the singular of dice, pick a card from a standard deck of cards, or choose a features editor from a 5-person newspaper staff. So here's the solution. So when we flip a coin, there are two possibilities, either heads or tails. So there are two ways that we can flip a coin. Now, there are 6 faces on a die, numbers 1, 2, 3, 4, 5, and 6. So therefore, there are 6 ways that a die can be rolled. And there are 52 cards in a deck, so therefore there are 52 different ways to choose a card from a standard deck of cards. And in the last one, there are 5 ways to choose one of the 5 staff members to be the editor. So the next thing that we're going to talk about is another example. So a group is planning a fundraising campaign featuring 2 endangered species. Now, 1 animal for TV commercials and 1 for use online. Now, the list of candidates include a cheetah, an otter, a black-footed ferret, and a Bengal tiger. So we're going to use C, capital C for the cheetah, capital O for the otter, capital F for the ferret, and then capital T for the Bengal tiger. So in how many ways can we choose 2 of the animals for the campaign? So the first thing is that we begin by assuming that C is the animal selected for the commercials, and then consider each of the other animals for the online campaign. So then we'll get CO, CF, CT. Now, doing this for all the animals, we get the following. So we have CO, CF, CT, OC, OF, OT, FC, FO, FT, TC, TO, TF. So those are all the possibilities that we have. So therefore, we have 12 different ways to choose the 2 animals. Now the next example is how many ways can 3 coins be flipped? So now what we like to do is do what we call the tree diagram. So let's assume that we're flipping a penny, a nickel, and a dime. So the tree diagram is a handy way to illustrate these possibilities. So the first thing is we're going to illustrate the possibilities for the penny. So the penny, when we flip it, as you know, flipping a coin, you either have heads or tails, so there's 2 possibilities. So now the next thing is we're going to illustrate the possibilities for the nickel after having already flipped the penny. So as you can see, we begin, so then we either have heads or tails, and then if we have heads, then when we flip the nickel, the possibilities are either heads or tails, and then the same thing, if we have tails on the flip, the possibilities are still heads or tails for the nickel. Now the next thing is we're going to illustrate the possibilities for the dime after having already flipped the penny and the nickel. Now we can trace 8 branches that indicate the ways that 3 coins can be flipped. So here's the first flip, which is the penny, the second flip, which is the coin, and then the third flip, which is the dime. So the first possibility is that we get heads, 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 or heads, heads, tails, or heads, tails, heads, or heads, tails, tails, which is this one right here. Then the other possibility would be tails, head, head, or tails, head, tails, or tails, tails, head, or tails, tails, tails. So those are the 8 possibilities. Now, if we roll 2 dice, how many different pairs of numbers can appear on the upturned faces? So here's the solution. We will use ordered pairs to form the red number and the green number to represent the pair showing on the dice. So we can roll a 1 on the red die and either 1, 2, 3, 4, 5, or 6 on the green die. So then the possibilities then would be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So let's go ahead and use the tree diagram to illustrate all the possibilities. So let's begin. So here we have all of the possibilities that we have when we flip 2 coins. So there are 36 possibilities. The dice, sorry. Now, here's another example. The director at a local TV station wants to fill 3 commercial spots using promos for the latest albums by singer Jordan, Taylor, and Carey. How many ways can these spots be filled if repetition is allowed? So, since repetition is allowed, then we can choose JTT, or we can, and then this will be abbreviated by JTT. So we can literally have JJJ, if you will, since we can repeat. So now the tree diagram illustrates all the possibilities, and we see that there are 27 ways to fill the promo spots. So here we begin. So we can have here J, T, or C for the first possibility, and then following that we can have J, and then the third will be J, so that's the JJJ, or the JJT, and so on, the JJC, and so on all the way until the CCC. So those are all the different possibilities that we have. So that's the first singer, the second singer, and then the third singer. So in how many ways can the promo spots be filled if in the previous example, if repetition is not allowed? So since repetition is not allowed, then we're not allowed to have the JTT. So then in this case, we have 6 ways to fill the promo slots. So here we have the first singers, JTC, so we can choose one of those 3. If J is already chosen, then TC is the only 2 choices. If JT is chosen, then C is the last choice if JT was chosen first. So here are the possibilities, the 6 possible ways to fill the promo slots. Now the next thing is a designer has created 5 tops, 4 pairs of pants, and 3 jackets. Now if we consider an outfit to be a top, pants, and jacket, how many different outfits can be formed without repeating the exact same outfit? So here's the solution. For a tree diagram, we will start with the 5 branches, those are the tops. Then we'll attach the 4 branches to each tops, those are the pants, and that's giving 20 branches. And then we'll attach the 3 branches for the 3 types of jackets, and then this will give us a total of 60 different branches or 60 different outfits. And that's the end of section 12.1. Thank you.